we can first base this off of the picture we did before, right? Where did the picture go? We want to prove cotangent is cosine over sine. So if I refer you to this picture that I already deleted, I want to redraw it. X, Y, something like that, right? From here to here is X, from here to here is Y, here to here is R, here's theta. We can prove that cotangent theta, and you should be writing this in the actual spot. I just kind of ran out of space here on my screen. We can prove it with the x and the y's, right? So cotangent by definition would be x over y. Cosine is going to be x over r. Sine is going to be opposite over hypotenuse, y over r. What happens is the r's cancel out, and you're left with x over y. But on the left side, we said cotangent was x over y. So they both check out. The left side is x over y. The right side becomes x over y. That's one way to prove this is true. Another way to prove that it's true is if you believe, like we proved already, that tangent of theta is sine of theta over cosine of theta, but we use a definition, right? If we reciprocate, you remember what the reciprocal is of tangent? The reciprocal of tangent is cotangent. But if I reciprocate the tangent, means I reciprocate this as well. That means I flip it upside down. Okay, so that's another way that we proved that cotangent is cosine over sine. So at this point, you got to know that tangent is sine over cosine, and cotangent is cosine over sine. Okay. Problem 4. So just in case you're not aware, let's go ahead and show you all the relationships that these guys have. So we have sine is 1 over cosecant. Cosine is 1 over secant. And tangent is 1 over cotangent. Which means that cotangent is 1 over tangent. Secant is 1 over cosine. And cosecant, snap, is 1 over sine. Any other class, any other trig teacher would have had you memorize all this stuff. It's a horrible waste of brain power. Your test is going to be open notes again. Okay, so just make sure you have all these things on there. You can go ahead and just use them. Don't worry about memorizing them. Problem 5. Who is this fellow? So I went ahead and took this off the internet, but there's something wrong with this. And what's wrong is the angle should be capitalized. So there should be capital B. There should be capital B. That's why I have in here capital B, right? Okay. How do we prove that sine B over tangent B is cos B? Snap. Well, why don't we start with what we've written down already 3 times. Tangent of theta is sine B. Oops, just try that again. We're doing B right now, angle B. Tangent of B is sine B over cosine B. Let's put this over 1. And remember, we kind of did this trick before where if you have this on the bottom but you want it on top, you just pretty much switch these two. If you don't remember that trick, let's go ahead and cross multiply this proportion. So I get tangent of B times cosine of B is equal to 1 times sine B. But that 1 doesn't really matter, okay? Because it's just a 1. We had it there just to help us out. I can divide both sides by tangent of B. And I get cos B is sine B over tangent of B. So in case if you haven't noticed this, recognize that we gave you all the answers. So with all these problems in this topic, we are giving you the answer. We're saying, here's a problem, get this answer. So what this whole thing is, this whole unit is about It's about proving, getting from one place to the next. Okay. Some of you are going to take some detours. Some of you are going to go the fastest. Some of you are going to go the long way. There's many ways to prove these things, right? If you're going to go from here to Vegas, there's, various ways you could do that, right? Okay, various means, various transportation. So same with these problems. You have a beginning, you have a destination, and you have to prove how you got there. Okay. For your summary, may I suggest you take a moment to go ahead and reflect on the following in your summary. How is the Pythagorean theorem different from the Pythagorean identity? What if we divide everybody by sine squared? Sine squared over sine squared becomes 1. It doesn't become 0. It doesn't cancel out. It cancels out, but it leaves you a value of 1. It's like saying 4 divided by 4 is 1, right? Okay. So this whole thing just becomes 1 because you divide it by itself. If it helps, let me break this one down. This is cosine of theta over sine theta squared. This is 1 over sine theta squared. Do you recall what is cosine divided by sine? What is 1 over sine? So this is another form of the Pythagorean identity. This one relates cotangent with cosecant square. Case number 2. Why don't you try it out? Why don't you pause me and try it out? Pause me. Hopefully you got the feel for this one. You divide everybody by cosine square. This results in this one becoming 1.
Most impressive.
In the arena of math, if you want to be accurate, it's important that you have good habits. So don't ever consider that you suck at math, because you don't. You just have bad habits. The more care you take and the more steps you take, the more understanding you demonstrate, and the better your answers come out. So I know some of you probably skipped this step where you went ahead and collected the square on the outside and organized things, but I'm doing this so you recognize this is sine divided by cosine.
That's all there is to it.
This is secant. And this is another form of the Pythagorean identity. So remember, the original Pythagorean identity is sine squared plus cosine squared is 1. But now we have two alternative forms of the same identity. Okay, here's a comic for you. Why was Alex having second thoughts? Yeah. Challenge. If Mom and Alex did have a son, oh snap, what would he be called? So we're talking about sine and we're talking about tangent. Okay. Well, let's kind of take a look. It probably wouldn't be as good looking as 1. So if we have sine squared plus tangent squared, well, I'm going to put this over. Let's go ahead and rewrite this. I'm going to have sine squared x over 1. Tangent is sine squared over cosine squared. Sorry, tangent is sine over cosine, but because it's squared, I can put it squared and squared. Now, you didn't make it the trig pre-calc without doing some fractions. You'll notice that these don't have common denominators. You need a common denominator. So I'm going to multiply this one by cosine squared x because that's the missing term.
Most impressive.
And you have a common denominator. You'll notice that they both have a sine squared. There's a plus right here. So I'm going to factor out sine squared x. That leaves me a cosine squared x and a plus something, plus 1. If Mom and Alex did have a son, this is what it would be called, and it wouldn't be a great comic. So now you know. Snap diggity. Okay, for your summary. And by the way, generally, I'm glad that we did this here. Undo this. Okay. Generally speaking, we express proofs in terms of sine and cosine. So we're not going to do the x and y's and the triangle like we did before. I know you're comfortable with that algebra, but that's algebra 1 stuff. That's fundamental proving. We had to do that for a couple of proofs on the first page. But from here on out, I fully expect you to use sine and use cosine and use some of the things we've showed you. Okay, so generally speaking, from here on out, we express proofs in terms of sine and cosine. And that's what we did here, right? I had a tangent, but I expressed as a sine and a cosine, and I'm just manipulating sines and cosines to get an answer. For your summary, explain a good rule to follow when working with trig proofs.